What should we do first? Okay, so hydrazine's acting as a weak. They're telling us it's a weak base. Okay, so we're not going to write in yellow. Okay, so we have N2H4 reacts with water. It's acting as a base. So what's it going to do? It's going to accept a proton. So we get N2H5, which means it is now positively charged, and we get OH minus. The charges have to balance on each side of the equation, so we're all good. Okay. It's a 1.5 molar solution of hydrazine. So we have 1.5 molar. Everything else is 0. Because that's the freeze step. We pretend that it's frozen in time. Then we release it to ionize. What's the change? What other information do I have that I can now calculate something on the right-hand side? We have the pH, just like our lab, right? This allows us to calculate the concentration of OH minus, because what does pH plus POH equals 14? So we know the pH, so the POH is going to be 14 minus 9.5, which gives us 4.5. What am I going to do now? D-log it. That's
10 to the negative POH.
Yes. So remember the formula, 10 to the negative POH equals the concentration of OH minus. So 10 to the negative 4.5 is going to be 3.16 times 10 to the minus 5. Yell at me if you disagree.
Too many sigmas.
We'll carry him until the end. (3.16 times 10 to the minus 5). So that means when we release it, the change is, whoa, we lose 3.16 times 10 to the minus 5 molar of the hydrazine, and it ionizes, so we gain 3.16 times 10 to the minus 5. 3.16 times 10 to the minus 5. Those are adding. Is 1. If you go 1.5 minus 3.16 times 10 to the minus 5, you're going to get 1.5. And then I'm just going to put those numbers there because I'm too lazy to write them. Okay. Then we write the KB expression like we've been doing for 3 chapters. It's a concentration of OH minus, concentration N2H5 plus over concentration of N2H4. Do we put the water in? Perfect. And then you hit a bunch of numbers on your calculator and you should get 6.7 times 10 to the minus 10-ish. Do we agree with that? That's essentially your lab question, except for the base, like what we did at the beginning of class today. Okay. All right. Last one. Determine the pH of a 0.5 molar solution of oxalate ion. Okay. So we have our C2O4 minus. We put it in water. What is the only thing that this ion can do? Accept a proton. It has no protons to give. The only thing it can do is accept a proton. Drops the charge by 1, and we get OH minus. Bye, Kaylee. Good luck with your thing tonight.
Kaylee.
Did I say Kaylee? Michaela. All right. We have 0.5 molar solution. We have 0 and 0. That's the frozen part when we dump it in. Then we release it. It ionizes. How much do we lose and gain? X, because we don't have the pH, right? If you had the pH, you could figure out what X is, but we don't. So we just go minus X, plus X, plus X. So 0.5 minus X, X, X. So we get a KB expression. Which is X squared. What can I make an assumption about for X? Real small. So we can say X is way, way less than 0.5. So the bottom is just 0.5. And that equals the KB. What do we do now?
On KB.
You got to go to your table. And what Ka are we going to look up? Yeah. So the Kb is when it's accepting a base going this way. But if you look at it from the reverse process, this is the Ka expression of HC2O4 minus, right? So if we go to our data package, whoops. There it is right there. A right here, hydrogen oxalate, has a Ka of 6.4 times 10 to the minus 5. So we go, okay. Find the Kb. We know that Ka times Kb is equal to Kw. And we say for Ka for HC2O4 minus. That's the Ka we're using. So Kb is just going to be 1.0 times 10 to the minus 14 divided by that Ka, which is 6.4 times 10 to the minus 5. Which gives us a 1.56 times 10 to the minus 10 kb. Then you plug it into that. So you should get X is equal to 8.8 times 10 to the minus 6 molar. Is that sounding about right? Okay. Now what? What does X represent?
The concentration of hydrogen.
Yeah. So this is X, which is this and this. But we want this. Why is this the one that's important to us? Yes, that'll give us the POH, which then will allow us to calculate the pH. Okay? So, so that is equal to concentration of OH minus. So we go POH is equal to negative log of that, which gives us 5.1. Which gives us 8.9 for our pH. Does that number make sense? If it turned out to be 2.3, would it make sense? Why? There you go. It is a base. It's producing hydroxide ions in solution, so we know it's a base. Therefore, the pH should be over 7, and it is 8.9. Okay? And if the Kb of it is 10 to the negative 10, which means it doesn't ionize a lot, right? So it should be a weak base. That is it. You can now finish those questions. Monday, you have a group quiz. We will